Good morning, student. Today we are going to start the new chapter for the 11th standard mathematics, differential calculus. The chapter number 10, differential calculus. First, you have to see the introduction of the differential calculus. Now, let us consider a car travels some distance, it is d, and starting at it is the time taken equal to 0, and travel some of the distance, and finally we get some of the time taken. To calculating of it is the distance, and by using of it is time and the speed. The speed will calculating of it is now the speed of the car calculated by distance travel by it is time taken. Distance travel by the time taken. So supposed to be the starting at 2 it is second. After some time it is time taken that is equal to 2 it is minute, and some of the distance are travel. Again some of the time taken that is equal to it is 5 it is minutes, and some of the distance are travel. And we have to calculating of it is speed and the time taken and the distance travel by applying of it is speed formula, the distance by time. By applying of this, it is ratio to calculating of it is speed of it is the car. Now, the concept of it is derivative by applying of the tangent line problem. Now, let us consider a curve y equal to f of it is x. Now, at any one of the point, draw a tangent line. The tangent at it is a p. Consider a point it is x naught, comma it is f of it is x naught. Let us consider it is y that is equal to f of it is x, and put it is x that is equal to x naught. That implies it is y that is equal to f of it is x naught. And x naught as a point, the corresponding and the value of it is x naught equal to it is f of it is x naught. At the point of it is p, we have it is a contact between of it is curve and it is tangent line. Therefore, it is draw a tangent to it is a curve at the point is p. It is called it is tangent line. By using of it is tangent line, and we have to derive the derivative. Now, using the tangent line, we have to find out the derivative. Now, let us consider the same it is y that is equal to f of it is x as a curve. At the point it is p, it is x naught, comma f of it is x naught as a point p. We selecting another it is a point that is called it is a q. Now, passing through of it is a pq, we draw a secant line. Draw a secant line. What is meant by secant line? A line cuts it is at the two places of it is a curve. That line is called it is secant. A line touches at it is one point, and that is called it is tangent. Now it is we draw a secant line, and it is p and q are two. It is intersection of the curve. Now already we know the point it is p x naught, comma f of x naught is called it is point is p. Now it is find out as it is point it is q, and this place is called defined by x naught, and this place is defined by it is f of it is x naught. Now sum of the distance from it is p2 as q, and thus distance defined by it is x plus it is del x. The changes in the x and defined by it is x naught plus it is del x. X naught is place, and after that x naught some of the distance or it is we have for it is q point, that the point defined by it is x naught plus del x, and we have it is y also. So for this it is y, it is f of it is x naught plus it is del x. The function value of it is x naught plus it is del x, and we get as it is a point is y value of it is q, that is defined by f of x naught plus it is del x, that is point it is value of it is y. Now this distance defined by it is del x. From it is x naught to this point defined by it is del x, and this distance defined by it is del it is y. That means it is what? From the total it is distance from origin to the function of it is x naught plus del x, and separating of it is f of x naught, and that is defined by it is del y. F of it is x naught plus it is del x minus it is f of it is x naught, and that is called del y. That is changes from it is p to it is q. That is q distance from it is p as it is del y, and from it is point is p to it is the distance x axis. It is called del it is x, and it is called it is del y and del it is x. Now by applying of it is 2 points, p is defined by it is x naught comma it is f of x naught, and another it is point defined by q is equal to x distance defined by x naught plus it is del x. X distance x naught plus it is del x comma y distance defined by it is function of x naught plus it is del x. Function of it is x naught plus it is del it is x, and that is called it is point it is q. Now p and q we know using the 2 point, and just find out as it is slope of it is secant line. Now find the slope of it is secant. That means what? It is applying formula y2 minus y1 by it is x2 minus it is x1. Applying of it is slope formula, if any 2 points are we know, apply 2-point formula to find the slope of it is a line, and line is called a secant here. Now what is the point? It is x1, y1, it is x2, it is y2. Now applying a formula x2, what is x2? F of it is x naught plus it is del x, it is y2 minus y1. Y1 it is called f of it is x naught by it is x2, that is equal to x naught plus it is del x minus x1 equal to x naught. So these two are it is cancelled, remaining it is f of it is x naught plus it is del x minus it is f of it is x naught by remaining it is denominated it is del x. That is called what? It is a slope. The slope defined by the slope of it is secant line. Slope of it is secant it is line. So we know that the slope of the secant defined by f of x naught plus it is del x minus f of x naught by del x is called slope of secant line. So we know the secant by using of it is 2 points, it is p and q. We obtained it is equation of slope of the secant line. Now suppose the taking of 2 points, it is p supposed to be here and q is supposed to be here. Draw a secant line. We get another line of it is equation of it is slope of the secant line. And similarly, keep continuing selecting of another it is point p and it is q, and draw a secant it is line. It gets like an equation of it is secant some other it is line, and keep going. One of the places we can p and q both are it is coincide with the point. In that place we draw it is a secant line. It is not a secant, that is a tangent line. That is a tangent line. So at a one point, when we get as one, both it is p and q or it is at same place, the distance of it is del x, and it become it is 0, tends to 0, and in that place the delta del x become it 0, the both p and q are it is going to the same place. Therefore, the slope of it is a tangent line is defined by limiting it is del x tends to it is 0, f of it is x naught plus it is del x minus it is f of it is x naught by it is del x. Therefore, the slope of tangent is defined by limiting del x tends to 0, f of x naught plus del x minus f of x naught by del x, and it is formula to find out the slope of it is tangent line. Now what is meant by derivative? So now the slope of it is a tangent that is defined by the limiting of it is del x tends to it is 0, f of it is x naught plus it is del x minus it is f of it is x naught by it is del x. It is called slope of it is tangent line. In this it is derivative, we can define by first derivative of it is a function. The f dash of x, y is defined by it is f of x. Now this function differentiate with respect to it is x, we can write as it is dy by it is dx, that is equal to f dash of it is x, that is equal to y dash, that is equal to y1. you can say the derivative as it is dy by dx f dash of x y dash or it is y1. Now this it is derivative is defined by it is f dash of x, and this f dash of x supposed to be the f dash of x x minus, and that is equal to limiting it is del x tends to it is 0, f of it is x naught plus it is del x minus it is f of it is x naught by it is del x, and then it is f dash of it is x plus, that minus mean it is we can take a line segment line, it is x takes the value supposed to be 0, and x minus mean it is taking the value, it is left side of it is x equal to 0, and x plus is called it is taking x equal to 0 as right side of it is x equal to 0, that is called left and right, negative and it is positive. So we can take it is minus is called it is left and plus is called right. And f dash of x minus f dash x plus is equal to limiting it is del x tends to it is 0, f of it is x naught plus it is del x minus it is f of it is x naught by it is del it is x. In this it is two cases, both it is derivatives, both the derivatives what f dash of x naught minus f dash of x naught plus both are it is supposed to be equal. If it is f dash of it is x naught minus it is equal f dash of x naught plus both are it is equal, then we can say that f is it is differentiable it is function at it is x naught, at it is x naught. So therefore the first derivative of negative side, first derivative of it is positive side, f dash of it is negative, f dash of it is plus, f dash of it is left, f dash of right at x equal x naught, and both are it is getting a same it is value, and both are exist first and get both are it is equal, then we can say the given function is differentiable at x equals. Based on the slope of it is tangent line, we solve some of the sum. The example number it is 10.1. Find the slope of it is tangent line, and to the graph of it is function given f of x equal to 7x plus it is 5 at any it is point x naught comma it is f of x naught. Now given that the function it is f of it is x is equal to 7 it is x plus it is 5. So now we can take it is the function, first of all it is we can take it is x that is equal to x naught, that implies f of it is x naught that is equal to 7 x naught plus it is 5, it is called function of it is given point it is x naught, and the function value equal to 7 x naught plus it is 5. Now it is for any delta is not equal to 0. Now we are applying of it is function value equal to f of it is x naught plus it is del x. That means what? We want to find out as it is f of it is x naught plus it is del x minus it is f of it is x naught by it is del x. And applying of it is limit it is x del x tends to it is 0. We apply this formula to find out the slope of it is tangent line. Therefore first we want to find out function of it x naught plus del x. So in the place of it is function value of it is f of x, we can replace x naught plus del x, that is equal to 7 of it is x naught plus it is del x plus it is 5. 7x plus it is 5. Now just multiply, that is equal to 7x naught plus 7 it is del x plus it is 5. Now it is f of x naught plus it is del x, we know the value. Now just applying of it is formula, the limit it is del x tends to it is 0, f of it is x naught plus it is del x minus it is f of it is x naught by it is del x, that is called it is what? That is defined by it is slope of it is tangent line, and limiting it is del x tends to it is 0, f of x naught plus del x, we know it is 7 x naught plus it is 7 it is del x plus it is 5, and minus of it is f of it is x naught, that value equal to 7 it is x naught plus it is 5 by it is del x, it is as it is, and limiting it is del x tends to 0, just remove the bracket, 7 x naught plus it is 7 del x plus it is 5 minus of it is 7 it is x naught, and multiply minus 5 by it is del x, it is as it is, plus 7 x naught minus 7 x naught both are it is cancelled, plus 5 and minus 5 both are cancelled. What is remaining? the limiting it is del x tends to it is 0, and 7 it is del x is remaining in numerator, denominator del x is remaining, both are it is cancelled. Therefore limiting it is del x tends to it is 0 and remaining it is 7. So there is no variable here. If you substitute as derivative 0, the finally become it is 7 as it is the answer. Therefore slope of it is tangent line, that is equal to 7. Example number 10.2. Same, find the slope of it is tangent line for the graph of the function is given f of x equal to minus 5x square plus it is 7x at the point of it is coordinate 5 comma it is f of it is 5. Now here it is given that the function f of it is x that is equal to minus it is 5x square plus it is 7 it is x. The given function f of x equal to minus 5x square plus 7 it is x. Now we can take it is when it is x that is equal to what here? X equal to x naught defined by it is 5. X naught is defined by it is 5. That implies f of it is 5 that is equal to minus 5 it is 5 whole square plus 7 into it is 5. That is equal to minus 5 into multiply it is 25 and multiply it is 35, that is equal to minus 125 multiply it is 25 into 5 plus it is 30 it is 5, separate the value minus it is 90. That means it is f of it is 5 value, function of it is 5, that is called f of it is x naught value is equal to minus it is 90. Now what we have to find next? The function value of it is 5 plus it is del x, that is called x naught plus del x, that is equal to the function value minus 5 into x value equal to 5 plus del x whole square minus 5x square plus 7 into x equal to 5 plus it is del x. Now just it is multiply minus 5 into take a square, it is a plus b whole square formula, 5 square is called it is 20, it is 5 plus it is 2 into 5 is called 10, it is del it is x plus it is del x it is whole square, a plus b 5 square plus it is 2 into a into b it is called 10, it is del x plus b is called del x it is whole square plus it is multiply inside the bracket 35 plus it is 7 it is del x equal to just multiply minus 5 into the bracket minus 5 into 25 minus 125 minus 5 into plus it is 10 minus it is 50 it is del x minus 5 into plus it is del x it is minus 5 del it is x square plus it is 35 plus it is 7 it is del x. Now separating of it is constant term minus 125 minus 35 minus it is 90 minus 50 del x plus it is 7 del x, separate the term minus 43 del it is x and remaining minus 5 it is del x square remaining, and that is function of it is 5 plus it is del x it is value. Now we know it is the slope of it is tangent defined by m tan and it is equal to limiting of it is del x tends to it is 0, f of it is x naught plus it is del x minus it is f of it is x naught by it is del x, and it is equal to limiting of it is del x tends to it is 0 and if the function of it is 5, f of it is 5 plus it is del x minus f of it is 5 by it is del it is x. Now what we have to do, just we have to separating of it is substitute the value of it is f of it is 5 del x minus f of x value, that is equal to limiting of it is del x tends to it is 0, the function value of 5 plus del x that is equal to we can obtain here, that is minus it is 90 minus it is 43 del it is x minus 5 it is del it is x square, it is first term minus it is f of it is 5 we know it is equal to minus it is 90 already we obtained by it is del it is x. Now just remove the bracket, limit it is del x tends to it is 0 minus it is 90 minus 43 del it is x minus 5 it is del it is x square minus it is minus plus it is 90 by it is del it is x minus 90 plus 90 both are it is cancel. Now just it is we have to remaining this term that is equal to limit it is del x tends to it is 0 minus 43 it is del x minus it is 5 it is del x square by it is del it is x. Now in this numerator del x one is possible to take commonly, that is equal to limit it is del x tends to 0, del x within the bracket of minus 43 minus it is 5 into del it is x by again we have it is the term is called it is del it is x, both are it is cancelled. What is remaining? And that is equal to limit it is del x tends to it is 0 minus it is 43 minus 5 it is del x only remaining. Now put del x tends to 0 mean this term become it is 0, that is equal to minus it is 43, that is called slope of it is tangent it is line. Therefore slope of tangent equal to minus it is 43. That's okay. Note, if f is a differentiable at it is x equal to x naught, then f dash of x naught equal to limit extends to x naught f of x minus f of x naught by x minus x naught. This is another it is formula of it is derivative by using of x tends to x naught, and there we applying of it is del x tends to 0, and in it both are it is equivalent del x tends to 0 or it is x tends to x naught, both are it is same, and f dash of x naught is equal to limit x tends to x naught f of x minus f of x naught by x minus x naught. Now using this formula we have to solve the sum. Testing the differentiability of the function f of x equal to modulus of x minus 2 at x equal to 2. So now applying of this formula, and first find out as it is function value, and when it is x is equal to it is 2, x equal to 2. Put x equal to this equal to modulus of x equal to 2 minus 2, that is equal to 0. Therefore f of it is 2, that is equal to 0. Now applying of it is differentiability condition, you know that the left limit f dash of it is x naught minus, and it is equal to f dash of it is x naught plus both are it is same, both are it is equal, then we can say f is it is differentiable at it is x naught. There is a condition. Now we find out as left limit and right limit. Now find out as it is left limit. And before that find out as left limit, just we have to discuss the modulus condition. We know about it is modulus. F of it is x is equal to modulus of it is x, that is equal to, if it is x is less than it is 0, the modulus of x value equal to minus x. If it is it is greater than or equal to 0, modulus of x equal to plus x. Therefore modulus of it is x, we can write x is less than 0, negative value of it is x, we can get minus x, positive value of x we can get it is x, f of x values are it is modulus of x equal to minus x and plus x in the case of x less than 0 or greater than or equal to 0. The same it is property we applied here for the function f of it is x, that is equal to modulus of x minus it is 2, and that is equal to, if it is x minus it is 2 is less than it is 0, and we have it is this value equal to negative, minus of it is x minus 2. That means it is x is less than it is 2, it transfer the term. And another case, if it is x that is minus 2, it is greater than or equal to 0, and it obtained it is a function modulus value equal to x minus 2. X minus 2, that is called x is greater than or equal to 2. And x is less than it is 2, the function value equal to minus of x minus 2, the x value equal to greater than or equal to 2, the function value equal to x minus 2. Okay, now apply formula for right property, f dash of it is x naught minus f dash of it is x naught, it is minus, that is equal to limit it is x tends to it is x naught minus f of it is x minus it is f of x naught by it is x minus it is x naught. Now here x naught value equal to what? X that is equal to it is 2. Therefore f dash of it is 2 minus, that is equal to limiting x tends to it is 2 minus x naught value equal to 2 minus f of it is x minus f of it is 2 by it is x minus it is 2, and that is equal to the function value of it is left condition, that is called 2 less than it is 2, like x less than 2, what is the x value? Function value x less than 2, the function value equal to minus of x minus 2. Therefore the limit it is x tends to it is 2 minus, the function value equal to minus of x minus it is 2 minus f of 2 value, f of 2 equal to 0, therefore 0 by it is x minus 2, it is as it is, and that is equal to limit it is x tends to it is 2 minus of it is x minus 2 by x minus it is 2, both are it is cancelled, and finally we have it is minus 1. That is therefore left property f dash of x to minus is called left. The f dash of 2 minus it is value equal to minus it is 1. Similarly, we find out f dash of it is 2 plus that is equal to limit it is x tends to it is 2 plus f of x minus it is f of it is x naught by it is x minus it is x naught. That is called x naught value equal to 2 here. Now that is equal to limit it is x tends to it is 2 plus the function value equal to x minus it is 2 minus f of 2 equal to 0 by it is x minus 2 as it is. That is equal to limit x tends to it is 2 plus and x minus it is 2 by it is x minus 2 remaining, both are it is cancelled, and that is equal to final answer equal to 1. That we will call f dash of it is 2 plus and it is equal to 1. Already we obtained f dash of it is 2 minus, already we obtained f dash of it is 2 minus, that is equal to minus it is 1. Therefore it is f dash of it is 2 minus is not equal to f dash of it is 2 plus. Both conditions are not satisfied. Therefore we can say f is it is not differentiable or it is x that is equal to 2. Next one of the exercise problem 10.1. Question number is 3. Determine whether the following this function is differentiable at it is value of it is given x. The function f of x equal to x into modulus of x, x equal to 0. So now we are applying of it is the right property and left property, and either it is both are equal or not. We want to verify. If it is equal, we can say differentiable. Otherwise, it is not a differentiable function. Now apply the formula. It is what is it? F dash of it is x naught. That is equal to limit it is x tends to x naught, and f of it is x minus it is f of it is x naught by it is x minus it is x naught. And this is a formula for derivative. Now applying of left property. Before applying the left right, just we have to find the function value of modulus 1. F of it is x that is equal to x modulus of x, and that it is x that is equal to 0 is given. Now that is equal to remove the modulus. If it is x is less than 0, the function modulus value equal to minus it is x and minus it is x. If x is less than 0, modulus of x equal to minus x. And another it is 1. If it is x is greater than or equal to 0, x into modulus of x become it is plus x. Therefore just multiply the function. That is equal to it is x into minus x minus it is x square. If it is x is less than 0, x into x it is x square. If it is x is greater than or equal to 0, it is called function of it is x. And using this function, just we have to derive the answer. First one, obtain left property. F dash of it is x naught, it is minus, that is equal to limit it is x tends to x naught, it is minus f of it is x minus f of it is x naught by x minus it is x naught. And that is equal to f dash of it is here, x naught is called what? It is x equal to 0. Therefore 0 minus, and limit it is x tends to it is 0 minus f of x is less than 0. What is the x function value? Minus it is x square minus f of x naught, and put as f of x naught means the function it is x equal to it is x in modulus of x, and put x equal to 0. Put x equal to 0, what is that? 0 into modulus of 0, that is equal to 0. Therefore f of 0 value equal to 0. Therefore f of it is 0. F of 0 value equal to 0 by it is x minus x naught value equal to 0. Here what is the x naught? X naught defined by it is 0 here. Therefore f of 0 that is equal to 0 and x naught value equal to 0. That is equal to limit it is x tends to it is 0 minus x square by it is x. 1x will cancel, and remaining limit it is x tends to it is 0 minus x remaining. Now put x value equal to what? X tends to 0. Put x tends to 0 and this value is x. Put x value equal to 0. Total value becomes 0. Therefore it is the left property f dash of it is 0 minus and that is equal to 0. Now similarly we have to find out as it is a right value. Therefore, f dash of it is 0 plus that is equal to limit x tends to it is 0 plus f of it is x minus f of it is x naught by it is x minus it is x naught. That is equal to limit it is x tends to it is 0 plus f of it is x minus f of it is x naught is called 0 by it is x minus x naught equal to 0. And what is function value of it is right? We know it is function value of it is x is greater than 0. X is greater than is called right. Supposed to be you can take it is x equal to 0 and this one is called plus, it is called minus. So it is called right, it is called left. Taking of x is greater than or equal to is called right. Value of function value equal to x square. Therefore limit it is x tends to it is 0 plus the function value equal to x square. F of 0 equal to f of 0 equal to 0 by it is simply it is x. And that is equal to limit it is x tends to 0 plus x square by it is x. So 1x will cancel. That is equal to limit is x tends to it is 0 plus x is remaining. And put x value equal to 0 and it become it is 0. Therefore right hand side value that is equal to 0. Therefore what is that conclusion? F dash of it is 0 minus and that is equal f dash of it is 0 plus both are it is equal, then we can say that f is it is differentiable function at it is x that is equal to 0. Therefore both left side derivative and right side derivative both are obtained same, it is value 0. Therefore both are equal, then we can say f is called differentiable at x equal to 0. Dear student, today we introduce the new chapter, the chapter number is 10, differential calculus. Now we know how to it is derive the equation by from it is equation of it is a line. The given function is given. How to find out as it is first derivative f dash of x. Applying of it is the derivative. How to find out as left limit, right limit. And if both it is limits are it is equal, then we can say the given function is called differentiable. And both are it is obtained different value, then we can say f is called it is a not differentiable function at given it is x equal to x naught. The remaining of the discussion will continue in the next class. Thank you one and all.